So before we get into the scenario of this section, I want to talk about building our own simple C2 implant and server. Being able to build your own custom tooling is essential for red team operations. Even though this course is mostly focused on the back end of setting up servers and configuring different things, it's still important to know how to develop custom tooling because even if you're the one setting it up, you should still fully understand how something works. Oftentimes, you're going to have to get into the code anyway to custom compile binaries for implants that you need to host or modify the actual C2 server code itself. So we're going to start off here with this simple C2 implant. I've selected Golang as the language to write our implant in. If you're not familiar with Golang, that's okay. The general prerequisite for this course is programming, so I'm going to go over this not at a level of understanding the Golang language, but just breaking down each section of code. I'm also not going to write it from scratch because I feel like, one, that would take too long, and two, it's more important that you understand the implementation choices and why we did things rather than language specifics. So if you're not familiar with Golang, but you want to learn it, I would suggest that you take some time to actually learn it and try to re-implement this yourself. Alternatively, if you're not familiar with Golang, but you are familiar with another programming language, even if it's just simple shell scripting or Python, try to take what you see here explained and re-implement that as an exercise. The goal here for you should be to actually get your hands on the keyboard and rewrite this yourself to some extent. Make improvements, make modifications. The point being that when you actually finish writing the code, you'll understand the way most C2 implants work fundamentally. So we're going to start off here at the very top where we're importing a couple things. You'll see a few items commented out. This is for logs and formatting. So there's a couple print statements or lines that are used for debugging and even error handling. So the program will crash and fail if something bad happens and it'll display an error message. We don't want our implant to ever crash and fail when it's actually doing something on a target. We also don't want it to display any output. The more logging we enable, the noisier it is. Now, that doesn't mean we never want implants to ever generate any kind of logs or artifacts. It actually could be important for your tooling to generate logs on a target, so that way you can keep track of things like timestamps or activities. But more often than not, you want to send those logs back to your C2 server and not actually log them on the target to generate further artifacts. It just kind of depends on what use cases you are. Remember, it all goes back to the TTPs. So other than those two items, everything else in here is something we're actually using. When it comes to Golang, if you're not using something, you'll actually get an error when trying to compile it. It likes you to only import what you need and only use what you import. So we're using the net HTTP libraries to do some HTTP requests, the net URL libraries to do some URL parsing, the IO utils to do some further input-output processing, converting raw byte data and stuff like that, regular expressions to actually parse out commands, and then the execution modules to execute commands. The time that we're importing, we'll actually see the use case for in the main function in just a second. Then we have this little third-party module. It's called shellwords. I actually found this reference in the Merlin C2 framework, but shellwords is basically going to help us parse out shell commands and construct a list so that way we can pass it more easily to the exec call. That's just because execing goes a little bit weird with how it handles arguments, and we want to make sure it's as streamlined as possible when we're passing in commands. Moving along to the main function here, we start off by defining a constant of command delay. And this is where we import, and this is where we use that time import. Basically, we're saying, hey, set a command delay for 10 seconds. This will actually be the interval at which our agent checks in. So our agent's only going to check in every 10 seconds. If you want this to check in at an even slower interval or a faster interval, you totally can. I probably wouldn't recommend setting it past maybe 5 seconds because then it may be checking in a little too fast for at least our C2 server implementation. But if you modify that, sure, you can tweak this however you want. But that's useful because sometimes we want our agent to remain dormant for longer periods of time. So we can crank this up if we need to. The next value I have here is this init variable. I have it set to 0 initially because this is actually us defining if this is the first time our agent has ran or at least successfully checked in. And you'll actually see that we're actually checking more if it's successfully checked in or not. We don't really care if it's running successfully because if it hasn't checked in, we know it's not running properly or something was configured already. We care about the first time it's ever checked in. The last thing we'll have defined here is an endless for loop. This repeats forever. So this is the primary loop for our program in the context of our main function. We actually call the get command function every time in this loop, and we'll pass it the init value, which starts out as 0, but this get command function will actually return an integer, and that integer will be used to reset the init flag to like a 1 or something. So that way we know the agent's already checked in, and we don't need to be told every time. We already know the agent's checking in, and every time it hits us thereafter, we're good to go. And lastly, we're finally using that time command again, and we're actually executing the sleep functionality that we've set the duration for up here. And the way we do that, we set that value of 10. So I said 10 seconds before. This is just kind of an arbitrary 10 value, but we take that and multiply it by time.second, which converts it to seconds. So We could use various other time attributes to convert this to other metrics, but we're doing it in seconds. So this is where we actually make it 10 seconds. And so it'll sleep for 10 seconds after calling the get command and setting this init, and then it'll loop again after 10 seconds and call the get command function again, which leads us perfectly into the get command function. This takes a parameter of init, which is an integer, which we've already talked about, and it will return an integer, which we'll use to reset that init flag. But that's all there kind of is to the initial setup. After that, we define a variable for the URL. It's a string, and it's actually where we're going to construct our C2 server URL. So whatever we define this URL as is actually where our C2 server lives. So this is like defining your L host in a reverse shell payload interpreter. So we first check if the init value is equal to 0. This means the agent's checking in for the first time. And you can use this kind of as like a PSK. You can have this as like a check-in, and you could use this to do further verification on the C2 server if the path doesn't quite match up. So right now I just have this set as agent check-in. And you'll notice that this is this weird AWS URL. It's not the IP of like a C2 server or something. This is because in this section we're going to be talking about C2 redirectors, and we're actually going to be using AWS's Lambda functionality to do that. So for all intents and purposes, think of this more like our c2url.thing.com, whatever the actual address of your C2 URL is, and then everything after the slash is actually what we care about when we're parsing later in our C2 server, and you'll see that. But we are actually going to be using the Lambda functionality, so this is what it'll end up looking like in the final product. If this isn't the first time we're checking in, we don't want to send the agent check-in string. We just want to hit the URL and let the C2 server know, hey, we're here. So that's what we do in this next line. We actually do an HTTP GET call on the URL. And so we pass in that URL, get the call, handle the error if we need to handle the error, and then save the response in the response variable. And you'll notice in Golang, this is a quick specific thing, you have to handle your errors properly. In this case, we have some log statements commented out from when we were debugging, but we don't want our agent just to crash if something bad happens. We want it to loop and try again. So anytime that an error does occur, we don't do anything with it when it's actually running on target. Instead, we just return 0. And this actually lets our main function know, hey, there was a problem. We're going to set init to 0. Agent's not checking in correctly. So the next time it loops around, once it checks in, it'll send the agent check-in string again and let us know that. So that way we can say, oh, okay, it probably didn't execute our command and it's rechecking in again now that it's kind of found itself and figured things out. The next thing we need to do is make use of that IOUtil functionality. We're going to take that response.body. So because this is HTTP request and we're using the HTTP libraries and we're saving that response in the response, we can actually just parse out common like HTML attributes such as the body. And the body is going to be pretty simple. There's not going to be any crazy HTML in it. We're just sending, a plain command. And so we're going to get the body and store that in the body variable. Same kind of error handling stuff here, but that's really all there is to it. So the body now contains the command we want to execute. And later we're going to need to send the output of that command once we've executed it. So I start out by defining a variable output here. In our case, it's a byte slice. And there's a reason for that we'll talk about once we get there. But for all intents and purposes, this could be like a string that's an output. Doesn't really matter too much. But we needed a specific use case that's for Golang. You just need to know that you need to find a variable to actually save the output for the command. Now we're using those regular expression libraries. So the first thing we're doing is defining a regular expression. This regular expression says, hey, at the start of whatever it is that we're going to match on, go all the way up until you find the first space. And what that means is basically if we have a command that is, ls tac la, just get this. And as soon as you see this space, don't care anymore and ignore it. So we're taking that, and so we're defining that regular expression, and then we're taking that and finding the substring match within the string representation of the body. So the body isn't a string right now. I believe it's actually might be in bytes, but we can simply cast it to a string and it'll work just fine. And so we'll get the substring, which will parse out that first command and save it in the command parsed value. Now this, when it's returned, actually stores a string slice of that value. Now, for some reason, it actually returns 2 copies of it. So to combat this, I just extract the first index and store that into the command. And this is going to be the actual command we want to run. The next regular expression we define is said, okay, after you see a space, anything else thereafter, just capture for us. So this will be all the arguments. So even if we have, ls tac la a dir, this is going to check for that space, ignore this, and then capture all this, and then also do the same thing, store it in a string slice. And it has kind of a similar issue where it will store it multiple times, and we kind of get around that the same way. But we have to handle it a little bit differently because we have to do that shell words parsing that I was referring to. So we define this arg string here first. Then we check if the length of arg parse is greater than 0. This is saying basically, hey, the slice isn't empty, or you may think of it as the array isn't empty. So we're just checking the length of the slice and making sure that it actually has something in it. If it does, we're going to do the same thing we did up here and define our arg as whatever the first index of that slice is. Then we need to parse those arguments. So we use shellwords.parse to actually get all of the shell arguments. This recognizes common shell commands. It parses all that and then stores it basically in a nice little string slice for us with individual args. This way it can be expanded later as actual arguments for our exec. And we'll store that in args. So now we check if the length of args is greater than 0, basically saying, hey, we have arguments and that the command isn't empty. If that's true, that means we have a command that also is passing arguments. And we simply use the exec command functionality to execute the command, and then we expand the arguments using this ... syntax. Basically, we're just passing in all the args for whatever the shell words parse functionality did. This will execute a command, and then we're also getting the output from that command and storing it in that out value that we defined up here. Alternatively, we may be passing a simple command like an ID or a whoami. So if this check fails, but we still have a command, the command itself isn't empty, we can just run a simple exec command with whatever the basic command is and do the same thing. And we'll store that in the out. And now is where we can break down why we define this variable as a byte slice up here. The exec command output functionality will return a byte slice. And so that's what's being defined here in our variable to start with, and that's what we'll be storing later once we actually get the output. So from there, we have our output, and we need to send that back to our C2 server. So now we have the send response function that takes an output string as the parameter. So that means we need to cast this byte slice to a string and then send it on over. So that'll lead us into the send response function. So like I said, we'll get that output, and then we'll construct a new URL. And this is going to be the same C2 server URL. So this is the same URL we initially communicated with. We're actually passing our output via the get parameter. So we'll basically use that URL library to construct a path for the GET request that takes our output as the value. So whatever the output is of ls-la, it'll construct this into a URL-friendly string and build our URL that way. Then we'll do the same thing that we did before. We'll just make a simple GET request and send that. And that'll send our C2 server the output, where it'll actually do more URL parsing before it displays the output to the end user. And we don't really care about returning anything, so we just don't want to save it, but we do want to handle our errors if something bad happens. So normally, like I said, we would log it and fail, but in this case, we'll just return if nothing happens. So that'll send the response to the C2 server. And then once that execution's finished, we'll actually return 1. So this is where we finally set that init flag. And then on proceeding executions, we'll just send this string on the initial connection, and that'll prompt us for a new command. So that's the Golang agent, but how exactly do we build it? Well, Golang is a compiled language. You can actually run it with the go run functionality in the command line, but at the end of the day, the benefit of Golang is that you can actually compile it for multiple systems. This agent in particular is actually able to be built for Windows, Linux, ARM, MIPS, Darwin, and honestly anything else Golang supports, but I haven't tested it on anything besides Windows, Linux, and macOS. So kind of use it at your own risk. In fact, the default compilation, if you just run plain make, will build you an agent Windows, an agent Linux, and an agent Darwin. So let's look at that now. So if we go into our simple C2 server implant directory and run make, it'll compile all 3 agents. And if we go look at our builds, we now actually have binaries that we're ready to drop on 3 different operating systems to target host across entire environments. That's really cool. And that's actually one of the reasons I like Golang a lot. And that's also why I elected to build this implant in Golang. It's really portable, really flexible, and really powerful too. So that's enough about the implant. Let's start talking about the C2 server code itself. So you may notice that this is not Golang, this is Python 3. I elected to write the C2 server in Python 3, one, because I wanted to show you all that the technologies you use to write your C2 server code doesn't really matter as long as you understand the fundamentals of how command and control works. So we could write a C2 server in Ruby, Python, Golang, it doesn't matter. There are pros and cons to choosing a specific language, but the thing about being the engineer on the back end is that you usually have control on what you install on your server. Now, there are edge cases where you're engineering from an internal environment, maybe using a compromised host as a pivot point or as a place to deploy further tooling and using it as like maybe an internal C2. There are some pretty significant edge cases you can get into with that. But overall, if this is like your primary C2 infrastructure that you're completely in control of, well, since you can run whatever you want, you can build the server itself in whatever you want. And we're pretty much always guaranteed to have access to Python 3 on our C2 server, so it was a good choice. Also, I wanted to mix things up a little bit because for those who may not be familiar with Go, there's a larger chance that you're familiar with Python already, so you'd at least be able to follow along with this a little bit easier. The last reason is that it's really easy to create an HTTP server in Python. It's not too terribly difficult in Go either, but it's really, really easy in Python. And so that'll give you the idea of what our implant is doing. You saw we were making HTTP GET requests, so this is an HTTP-based implant. So the first thing we're going to do is actually here at the bottom. So we've defined a run function. And the first thing we'll do is just say, hey, we're starting our simple C2 server, give you some nice friendly output as a response to the user. Then you need to select what address you want to bind to. Here, by default, it's localhost, but you change this to whatever interface or all zeros if you want all interfaces. And then the port that you're going to bind to. So if you want to do port 80, port 443, whatever have you, this is where you'll define that. Then you'll actually define the HTTP server object, and you'll store that in HTTPD. And once you've done that, you basically initialize the server. To start it, you just say HTTPD server ever, and this basically starts a Pythonized daemon of sorts. As long as this Python script's running, this HTTP server will keep running. And then we'll start the program by calling that run function. Well, since we're using the actual HTTP server object, what we can do is modify the request handler class to do the rest of our C2 server logic. From there, anytime the object is called in the context of our program, it'll reference what overrides that we put in the class instead of using the defaults. The main thing we do, since we're doing everything based on GET request, is just override this doGet method. So the doGet method is basically whenever the HTTP server gets a GET request, what do you want to do with it? So we actually have this really nice reference to just get that path that we care about. And this is just going to get everything that's, slash and afterwards. It doesn't really care about what the URL is. It's just the path in the URL. So the first thing we want to do is say, hey, is this that agent check-in? And this is where I say you could actually build this out to make logic. This could be like a pre-shared key of some sort where you fail out and deny the agent if the keys don't match based on what you put in the agent initializer and here. So that's kind of cool. Otherwise, it'll just let us know the agent is ready if it's the first time it's checking in. It's just a nice to let us know, hey, I'm here. Otherwise, if you get anything else that isn't just a slash, so it's not just a normal check-in, that means there's actually data there, and it's not this agent check-in, it'll be other data. So we're expecting command output, basically. So we'll do some URL lib parsing, and we'll unquote everything. So this is basically deconstructing the URL output for us so we can actually see it as text, not as some URL encoded string. So this will unquote that and parse it out for us, and store that in the output. And then we just print it out. So we say, hey, the agent returned whatever the output is. The next thing we want to do is actually prep the response. So when the Merlin agent does the GET request and sends us back data, it's going to then be on a cycle to get in its next loop to get its next command. So we supply that here. So we'll ask the user for an input. You type whatever you want, LSID, and then we'll send a response. So we'll send a 200 code, send back some basic headers, and then we'll actually write that response, that command that we put up here. And that'll basically return a blank page with whatever the command is in the response body that the agent will then pick up and parse out, as we've seen on the other side. And that's all there is to it. Now, this is a little glitchy. Because the agent is on an interval just checking in and checking in, we don't have any compensating controls here for Python. So every time we get a new GET request, if we're still stuck on this command and we haven't issued a command in a while, we may have to wait for things to catch up a little bit. So it can be a little glitchy if you're not actively interacting with it, but it's supposed to be just a simple proof of concept. This is how you build custom C2 tools. And so since we have some room for improvement, a challenge for you is after you're done with this section and you actually see it in action, is go use it, play around with it, and make improvements for yourself. I can already call out a couple areas where you can improve, like parameterizing the server address string. So on startup, you can just specify the interface instead of having to hard code it. Over in the main Go, maybe extracting the URL into a parameter, or at least into its own global value, so you can only have to set it once. Stuff like that is really valuable improvements to make streamlining the deployment of your agent and your C2 server much better. All right, in the next lecture, we'll be diving straight into the scenario, and we'll actually make use of this at some point later on in the scenario. I hope you learned something about how to develop your own custom C2 tooling, and like I said, I highly encourage you to play around with this some more and get familiar.